Hello and greetings to everybody. So, welcome to lesson 4. And so we're still on chemical change. So today we're going to look at the empirical formula. Okay. How to find the empirical formula. So so let's read the question together here. So this is question 6. Okay. And this question um, is from September. So it's a common test, September 2024, and it's from KZN. Yes. So it was a common test on KZN 2024. The question says 6.1. An organic acid made up of carbon C, hydrogen H, and oxygen O only only has the following percentage composition by mass. Okay. So carbon 48.85%, or 4.65, sorry, 48.65, hydrogen 8.11%, oxygen 43.24%. Then 6.1.1, they say define the term empirical formula in words. Okay. So what is empirical formula? The definition. Okay. It is what? It is the simplest the simplest is the simplest whole so the definition here is the simplest whole number ratio. The simplest whole number ratio of atoms in a compound. Simplest whole number ratio of the atom in a compound. And then we're supposed to determine the empirical formula of this compound. So, like I said, we use the table here. So the table will have 3 elements. Okay. So we should draw the table here. The table will have 3 elements. Okay. So the first thing we have here is the element. And then we have G over 100G. And then we have the number of moles here. So we divide by the molar mass in this column. And then in this case, we have the last one, the simplest ratio. Simplest ratio. So there are gonna be three elements. Okay, it's gonna be C, and then there's gonna be hydrogen. The hydrogen is written here, and then the last row is gonna be for oxygen. So there are three elements: CHO. And then, so we check the percentages. Okay, so for carbon, it's 48.65. So the 48.65 comes here. Okay, 48.65, and then 8.11 for hydrogen, and then 43.24 for oxygen. So 43.24. And then we come to the next column here. So this is where we have to get the number of moles. So we take what we have, all the numbers. So here we have 48.65. And then here we have 8.11. Then we also have 43.24. So we divide by the capital letter and we get it from the periodic table. Okay. So for carbon, it's going to be 12. For hydrogen, it's going to be 1. For oxygen, it's going to be 16. Okay. And then we're also, so the answers from this. So here we're going to get 8.11. And then the others, you use a calculator here. So I get 4.05. Then divided by 16. Then we get 2.7 here. And then the numbers that we get here will go to the top. Okay, so then you have 4.05 here. Then this number goes here. So it's 8.11. Then the 2.7 comes here. Okay, so now what happens? To get the simplest ratio, what do? We come here for the number of moles and we get the smallest number here. Okay, so we compare the numbers here and we get the smallest number. So in this case, R3 is 2.7. So the 2.7 is the one that's used to divide everything. So here we're going to get 1, and then we divide 2.7 everywhere because 2.7 is the smallest number. So this over here gives me 1.5. And then this over here gives me gives me 3. Okay. Now, we don't want, for the simplest ratio, we don't want decimals. Okay. So here we have 0.5. Okay. Meaning we're going to multiply everything by 2. Okay. So, okay, so let me show you this. So if you have, maybe let me do it here, because there are multipliers that we use here. Okay. If you have, let me say, if you have 0.5, yeah, you multiply by 2. If you have 0.33, you multiply by 3. If you have 0.66, you also multiply by 3. So 0.5, what does that mean? If you have 1.5 or 2.5 or 3.5, anything 0.5, you multiply by, you use the multiplier here, okay? And then if you have anything 0.25, you multiply by 4. And then if you have anything 0.75, you also multiply by 4. So if, for example, we had 1.25, instead of 1.5, if we have 1.25 here, it means we're going to multiply by 4, okay? If we have 1.33, then we're going to multiply everything by 3. So this is 0.5 here, okay? We have 0.5, so it means we should multiply everything by 2. So we multiply 1 by 2, we get a 2. We multiply here by 2, we get a 6. We multiply here by 2, we get a 3. Okay? So this means that therefore the empirical formula the empirical formula empirical formula is the empirical formula is C3H6O2. So so this is the empirical formula of this compound. So if there was no decimal here, then we would get our ratio from here. But then our ratio had to be outside the table here because we have a decimal here, so we have to multiply everything by 2. So it depends on the decimal that you have because that's the one that tells you the multiplier that you're going to use. See, so if there was 0.75 or 0.25, then we were going to multiply by 4. And then the other ones is what? It's anything 0.2. In this case, we would multiply by 5. So if we have 0.2, 0.2, or 0.8, then you would multiply by 5. So again, these are the multipliers that we use here. So if it's 0.2 or 0.8, we multiply by 5. Point 2 or 0.8. So now, Let us go to 6.2. Okay. 6.2, what they want. Okay, let me do it here. 6.2. So 6.2, let us read the question. Let us read the question and let's see what is required here. They say what? An unknown metal Y reacts completely with sulfuric acid according to the following balanced equation. 13.8 grams of metal Y is required to completely react with 0.4 cubic decimeters sulfuric acid of concentration 0.75. Okay. Use the relevant calculations to determine the name of metal Y. Okay. So what we have here is that the sulfuric acid, there is the volume and the concentration. So the first thing we can do here is we can find the number of moles of the sulfuric acid, because we can use C equals to N over V. So then we can then say, we can cross multiply here. We say, therefore, N equals to C multiplied by V equals to 0.75 multiplied by 0.4. Then we multiply the two. And then we get 0.3 moles. So we have 0.3 moles of what? Of sulfuric acid, H2SO4. This is the number of moles that we have. And then, so from there, if we have the number of moles like that, then we can then find the number of moles of Y. Okay, because the ratio here, we use the ratio Y to sulfuric acid. Okay, the ratio according to the balanced equation here is 2:1. Okay, 2:1. So it's 2 and 1. So we have 2 and we have 1. So here we have what we found 0.3. Okay, 0.3, and then here we have X. We don't know how many moles are there. So we're going to find X, say 2, we cross multiply. Okay, 2 multiplied by 0.3, and then we divide by 1. So it's going to be 0.6 mole. 0.6 moles of what? Of Y. So now we have the number of moles for Y. So what then we can then say, okay, then we can then say N equals to M over M. And then we can substitute. We can then say, therefore, this is going to be 0.6. 0.6 equals to M and then capital letter M. The capital letter is the one that's going to tell us what is going on here. So the mass, we have the mass, the mass is given here as how much? In the question, they say 13.8 grams of metal Y. Okay, so for metal Y, we're going to say 13.8. And then we say, therefore, M is equal to 13.8 divided by 0.6 equals to, so it gives you 23 grams per mole. Okay, so it means that this is the molar mass. This is the molar mass. So this is the molar mass. So we must go to the periodic table and look for this. Okay, so we go to the periodic table. We look for a molar mass of 23. Okay, is here. Is sodium is Na. Is Na. So we go back. So this means that therefore Y is sodium. Y is sodium. Na. Na. So why is sodium? Because this is what we get. We get 23. And we saw that 23 there is sodium, according to the periodic table. Okay? So what is what we had to do here? We had to find the number of moles of what? Of sulfuric acid, so that we can use the ratio here to find the number of moles of element Y. And then after we find the number of moles of element Y, 0.6, then we use it here to find the molar mass, because the molar mass is the one that is obtained from the periodic table. So then 13.8 will come here, is the mass that we're given in the question, and then we change the subject. We get M, which is 23 grams per mole. So 23 grams per mole corresponds with sodium, Na. So that is it for this question. Okay. So leave your answers, leave your questions in the comments, and thank you for listening. I'll see you on the next one. Take care.